Alright, in this video we're going to look at rational functions where the numerator is not 1 or a constant. It might end up being that way, but that's not the general look we're looking for. Now there are a number of cases for this. The first case we're going to look at is when the degree of the numerator, so the degree of the numerator, okay, is less than the degree of the denominator. Okay, so earlier on we had the functions in the form of p of x equals d of x over, or f of x equals, so it's right here, f of x equals n of x over d of x. So in this case, the degree of the denominator is going to be bigger than the numerator. Okay, so let's take a look at an example here to see what happens to the end behavior. The end behavior is when x goes to infinity, so really out far to the right, or really out far to the left, when x goes to negative infinity. So let's put up a quick, easy example here to analyze this, and I'll show you a trick. So for something like f of x equal to x over, let's do an unfactored one, x squared plus 2x minus 5. The degree of the denominator here is 2, and the degree of the numerator is 1. So it satisfies our condition here that the denominator has the higher degree. Okay, so to analyze when x is really large, close to infinity or negative infinity, we're going to look at f of x in a little different form. We're going to multiply the top and bottom by the same thing, so do nothing rule. Okay, so it's doing nothing to the function, and what we're going to multiply it by is 1 over the degree of the one on the top here. Okay, so 1 over x and 1 over x. Multiply the top and bottom by that, and we're going to see what happens here. Okay, so if we do this, now this doesn't help for when x equals 0. It actually adds a restriction that x can't equal 0. But we're not analyzing at the moment about when x equals 0. So we're looking at right now the end behaviors. Okay, so end behaviors is as x goes to plus or minus infinity. Okay, so that's what we're looking at the moment. So when you multiply by that, well, x times 1 over x is just 1. Okay, and then x squared times 1 over x, well, that's x. 2x times 1 over x is just 2. And negative 5 times 1 over x is minus 5 over x. Okay, so you're multiplying this by each term in here. You're distributing in. Okay, so as x goes to infinity or negative infinity, these two are exactly the same. So let's see. Now, how can I look at this when x goes to infinity? So as x goes to infinity, well, this is pretty much f of x is approximately equal to 1 over x. Why? Well, because 5 over a really large number is pretty much 0. Okay, so 5 over a billion is close enough to 0 that it becomes negligible compared to a billion. So a billion plus, or a billion minus 5 over a billion is basically a billion. And a billion plus 2 is really close to a billion. So these two pieces here pretty much end up being negligible when we're looking at x going to infinity or negative infinity. So as x goes to plus or minus infinity, f of x is approximately 1 over x. And we know the end behavior for this. The graph of that is like that. Okay? So whenever the degree on the bottom is greater than the top, Well, we're going to end up with either 1 over x or 1 over x squared. So if that was a cubic on the bottom, then this would end up being a squared here. And then you'd have 1 over x squared. And the end behaviors of that are fairly similar. So you can tell that as x goes to infinity or negative infinity, that the function tends towards the x-axis. And the x-axis is a horizontal asymptote. Okay, so we could try another one here. We could do f of x equals, let's say, x squared plus 3x all over x to the 5 plus 2x squared minus 4. And then if we're going to analyze this as x goes to infinity, well then f of x is equal to x squared plus 3x over x to the 5th plus 2x minus 4. I'm going to multiply the top and bottom, this time by 1 over x squared. Okay, so I'm multiplying by 1 over the highest degree on the top for this one. And that ends up becoming, well, 1 over x squared times x squared is 1. And then this ends up being plus 3 over x. As x goes to infinity, this is negligible. And then x to the 5th over x squared, well, that's going to be x cubed. 2x divided by x squared is going to be plus 2 over x minus 4 over x squared. Okay, and as x goes to plus or minus infinity, well, this piece here, the 3 over x, is pretty much 0. This is pretty much 0, and this is pretty much 0. So as x goes to plus or minus infinity, you've got f of x is approximately 1 over x cubed. And the end behavior for this is as x goes to infinity, 1 over x cubed gets really small, right? So it goes to 0. So in this case, you end up with 1 over x cubed looks like 1 over x, slightly different shape, that's all. So as x goes to plus or minus infinity, for both of these cases, for this one here, then f of x is approximately that, and y goes to 0. And this one, y goes to 0. Okay? So now we know what the end behaviors are going to look like for these functions. Basically, you take the highest degree on the top and divide it by the highest degree on the bottom. And so it's going to be, for this quadratic over a quintic, it's going to be 1 over x cubed. For a linear over a quadratic, it's going to be 1 over x, and so on. Okay, so hopefully you get the idea of that. And that will help out with the end behaviors.